Okay, and number 10. Number 10 is actually pretty simple. You can, I guess, solve this using product rule, but for now I'm going to solve it using logarithmic differentiation. So ln y equals ln and then e to the 2x squared plus 5x plus 6, right? And then we're going to put the exponent outside. So ln y equals 2x squared plus 5x plus 6, whole thing multiplied by ln e. And then everyone knows that ln e is just 1, right? So that means ln y equals 2x squared plus 5x plus 6. So 1 over y dy over dx equals 4x plus 5, right? And then dy over dx is equal to 4x plus 5 times e to the 2x squared plus 5x plus 6. So, I mean, this answer probably is pretty much expected, because if you solve it using the chain rule, like the way that we would normally do it, then we would get the same answer, right? So y prime equals derivative of the inside function, I guess, which is 2x squared plus 5x plus 6. That means 4x plus 5 comes out to the front, and e to the 2x squared plus 5x plus 6 comes out, or not comes out, or just stays there. So this will be our answer, which is the same as this, right? So this example is just to show you that either way works, and then logarithmic differentiation is also an accurate way for you to find your answer to differentiations, as long as you use them properly. Okay, and then going off to number 11. Okay, so y equals x to the x power times 1 minus x squared to the power of 2 all over 3x plus 3 to the power of 3. So ln y is equal to ln of x to the x power 1 minus x squared to the 2 and then 3x plus 3. It's always good to write this one out like this to show that you're actually applying the ln rule. So make sure that you're actually showing this in your future works. So this would be your first line of work that is like kind of important. And then number 2 would just be to spread these out. So ln y equals ln x, right? X times ln x, because the exponent goes out. Ln x, and then plus, since it's the product, and then we also have an exponent here, so 2 goes out, ln 1 minus x squared, and then minus, because it's a division, ln 3 ln 3x plus 3. Okay, and then now we derive, so 1 over y dy over dx equals, so use quotient rule, well, not quotient rule, sorry, product rule. So this would be ln x plus x times 1 over x, which is 1, so we're just going to write 1, plus 2 times 1 minus x squared, and then negative 2x right here, minus 3 over 3x plus 3, which is, we have to do 3 right here too. So that means number 4, dy over dx equals ln x plus 1 minus 4x over 1 minus x squared minus 9 over 3x plus 3. All of this multiplied by y, which is, again, pretty complex, right? Okay. Okay, so this will be our answer. Number 12, y equals 3x to the power of x to the third. Okay, so ln y equals ln of 3x to the x third power. Ln y, that means equal to x to the third power times ln 3x, right? So 1 over y dy over dx is basically equal to, use product rule, so 3x squared ln 3x plus 3x over 3, which is just 1 over x, times x to the third power. This means dy over dx is equal to 3x squared ln 3x plus 3x squared over 3, or just x squared, honestly, right? X squared, this cancels out. And then all this multiplied by y, which is 3x to the x to the third power. So this will be our answer. Number 13, our second to last question. Y prime equals, or no, not y prime, have it. Ln y equals ln 7x to the power of 7x, or ln y equals 7x times ln 7x, right? So 1 over y dy over dx equals, product rule again, 7 times ln 7x plus, well, 7x over 7 would be 1 over x, right? So 1 over x times 7x. So dy over dx would be 7 ln 7x plus 7 plus 7 times 7x. Yep. This will be our answer. And then number 14. This is a word problem. Find the derivative of y equals 6x minus 4 over x squared minus 6 using logarithmic differentiation. Then verify your answer by taking the derivative using quotient rule. So it's not really a word problem, but it's a little bit longer, I guess. So ln y, first method. Ln y equals ln of 6x minus 4 over x squared minus 6. I would say if I were put in the situation where both methods seem equally valid, I would probably choose logarithmic because it's a little bit, I feel like it makes a little bit more sense to me and it's less complex to me, for me at least. So yeah, 1 over y, no, before that, you need to distribute this. Y equals ln 6x minus 4 minus ln x squared minus 6. So 1 over y dy over dx equals 6 over 6x minus 4 minus 2x, right? Chain rule, sorry. 2x, and then x squared minus 6. And then dy over dx is basically equal to 6 over 6x minus 4 minus 2x over x squared minus 6, whole thing multiplied by our y. Okay, and then our method number 2 is just quotient rule, right? Y prime equals 6. 6 and then x squared minus 6 minus 2x times 6x minus 4. So x squared minus 6 to the power of 2. So that is basically and then plus 8x all over. Or no, negative 6x plus 8x minus 36 all over x squared minus 6 to the power of 2. So let's just verify this really quickly. So we have to distribute, I guess. Right, so 6 times 6x, 6 over 6x minus 4 times 6x over 4 minus x squared minus 6. So that would be, the denominator and the numerator would cancel since they're both 6x minus 4. So that means we have 6 over x squared minus 6. And then we also have negative 2x times 6x minus 4 all over x squared minus 6 to the power of 2, right? Okay, so this is equal to x squared minus 6 times x squared minus 6, so combining denominators, minus 2x times 6x minus 4. This is basically 6x squared minus 36 minus 12x squared plus 8x all over x squared minus 6 squared. This looks a little bit familiar. So negative 6x squared plus 8x minus 36 all over x squared minus 6 to the power of 2. So these two are actually equal, which is valid, right? So normally I think you should write like a justification for this. So, I mean, just write as the logarithmic differentiation result is this, write this out, right? And that is the same as the quotient rule differentiation result of this, which is why both methods work, and the derivative of 6x minus 4 over x squared minus 6 is equal to negative 6x squared plus 8x minus 36 all over x squared minus 6 to the power of 2. Yep, that's it.